Hi, thank you for watching this tutorial video on the rolling vertical landing in the AV8B Harrier. So in this video I'm going to go over the concept of the rolling vertical landing, when and why it's used. Then I'll go over the pre-landing data assignment, the cockpit configuration, and then the approach, and finally the landing itself. So the rolling vertical landing is typically used in one of two scenarios. Firstly, where you want to be as expedient as possible getting on the ground and getting out of the way at a large airfield, and that's the most common use. Or when you're operating at a FOB and you want to maximize your bring back weight, say in a counterinsurgency type scenario where you may not use up all your munitions, or even in a symmetrical warfare scenario where maybe your mission was scrubbed and you still want to bring those munitions back because they can be used later date and also they cost money. But you want to maximize your use of the landing area available, which at a forward operating base is going to be quite constrained. So this is a form of landing that will allow you to stop in the shortest possible distance, but also allow you to bring back weights that the vertical landing does not allow. It's also used in emergency scenarios when doing shipboard operations. So first of all, we're going to go through the pre-landing data assignment. You should either perform the pre-landing data assignment when you're in the cruise, and that assumes that maybe you've taken off from a larger airbase and you're flying out to a FOB where you're then going to rearm, refuel, and then go back out and conduct your mission. Or if you took off from the FOB, you would have done your pre-landing data assignment on the ground. That would be your pre-takeoff data assignment. So in this case, I'm going to assume the latter for the expedience of time. So all I'm going to do is I'm going to come into the VRS computer here, and I'm going to have a look at my vertical landing values. So we can see here it's saying that with water on, I can land with 1,773 pounds of fuel. So let's do some maths. So I've got 3,100 pounds there, so that is 1,400 pounds in excess of the limit posed there. I'm rounding that conservatively. You can see that I am carrying two JDAMs, two GBU 54Bs Mark 82 series JDAMs. So that is approximately £1,000 each. So we're £1,300 over there. We've got £1,000 of bombs. So that's 2,300. Let's round that up to 2,500. So for about that weight, we're going to be looking at a ground speed in the terminal phase of the approach of about 50 knots ground speed. Okay, if you were too heavy and you had fuel to play with, obviously stores are more difficult to come by than fuel, so you might choose to dump some fuel in order to meet the desired landing weight. Okay, cockpit setup. So first of all, I'm going to raise my seat because I like to sit up a little bit for VSTOL operations. Gives you really good visibility over the nose. I'm then going to open the EHSD on the left MPCD, and I'm going to open the DMT on the right MPCD. I've got my waypoint down there. I'm going to designate it, and I'm going to confirm that it is where I want to land. That is correct. That is the center of 3 DHLAs, so I'm happy with that. So we will come out of the DMT here, and we'll go over to the hood, and we'll bring that up. If you needed to sweeten it, just move it around using the TDC, press the TDC depress button to update the waypoint. If you want to create a new waypoint, then use the target of opportunity mode to create a new waypoint or mark point. Next, I'm going to leave the scale as it is for now, but I'm going to put our course line in, which is 338 degrees. Okay, perfect. Next, I'm going to set us up for the approach. So we're going to look to start the approach at 4 miles at 1,000 feet. So let's just bring ourselves down. We're going to descend. I'm going to fly out to meet that approach. Again, if you wanted to have a more accurate approach position, you could use the waypoint offset, and then from the waypoint offset, designate that waypoint offset and use target of opportunity mode to create either a mark point or a waypoint as desired. Okay, so roll wings level there, and we're just flying parallel to the intended approach direction. We can see over there is our designated helicopter landing area, or DHLA. Okay, so I'm going to bring the power out, and we're going to let the aircraft slow down. We're going to turn for about 4 miles and descend down at 1,000 feet. Another thing which is important to note is I'm recording this directly off the back of the rolling vertical takeoff video, so my QFE is set. That's something that you will find is common on a training sortie because you're obviously doing the circuit patterns and you're being critiqued a bit more closely, but in an operational environment you would obviously set the field elevation in the field data correctly, and you would use the QNH, and then you just add or minus rounded to the nearest 100 feet to your gate and checkpoint and circuit altitudes and whatnot. Okay, so we're below 300 knots, so I'm going to bring the flaps down to the STOVL position, I'm going to bring the gear down, and I'm going to put the mast mode to STOVL. And we're coming up on the extended runway center line, so I'm going to decenter my map there, and I'm going to bring the scale down once more. Okay. So the straight in rolling vertical landing, something you probably won't do all too often, more typically done just for practice. You'd normally do it after joining the circuit, even if it is a reduced height circuit. So 4 miles at about 1,000 feet is my recommended starting point. So we're at 4 miles at 1,000 feet, we're still turning on to the desired heading. I'm just going to adjust my power for rate of descent, and I'm going to use my stick for airway, and I'm going to bring the nozzles back to 60 degrees now. Water's going to go in the landing position there. Okay, and I'm looking for about 800 feet at the 2 mile point. I'm going to bring ourselves right there. Obviously, in certain environments, it can be a little bit difficult to see your designated landing area, so use all the sensors you have to help you update, but always make sure that you are updating a visual picture. So there it is, just off our nose. If you can't see it, there's no point in having all the system designations. You should use them to help you see it. So we're going to start descending just now, and we're going to descend as though we were approaching for the 150 foot point over the prepared surface. Once I get close enough that the designated landing area is about to drop under the tip of the nose there, again why I've raised myself up, I'll then adjust the power to make a 500 foot per minute descent rate for the near side of the prepared surface. Okay, and at about 1.5 miles, I'm happy with my distance. I'm going to start, as I'm trimmed for airway and rate of descent, I'm going to start bringing the nozzles back to adjust my ground speed for about 50 knots. So let's go back to 77 there. Note how that transitions me to having more of my lift produced by the engine and not the wings. So I get an increase in rate of descent. And notice there, I brought the nozzles forward a little bit to maintain that 60 knots ground speed. Okay, we're at 1 mile, we're at 450 feet. Our airway is a little bit low, so we'll be going a little fast. There we go, that's close enough for government work with the nozzles, so we're going to set the nozzles and just leave them there. 420 feet, so we're a little bit high as we approach the key. 0.6 miles, yeah, so a little bit high on the key, so I'm just going to increase that rate of descent. Okay, so the designated landing area is about a finger's width away from the nose, so I'm just going to adjust the rate of descent to put it where I want it. See, that's a really rapid drop, and then bring the power back up to make that 500 foot per minute rate of descent, and adjust the nozzles as we get in close, and hold the brakes. And we did miss the designated landing area there, so a little bit of an error in judgment. However, we have stopped in the desired distance. So I hope you found this tutorial useful. Obviously, it's important to practice this one because if you were landing in a fob where maybe you have trees in the way, you can't have a shallow descent rate, so you need to have that increased descent rate, as I tried to demonstrate there. But matching that with judging the landing points that you actually maximize your use of the prepared surface is really difficult. So make sure to practice it and never be afraid to go around. In an actual real world scenario, as demonstrate, if I was doing that landing, you would want to go around. You wouldn't land as I did there. It wouldn't have been safe. So to recap the important points, you want to be about 800 feet when you're at 2 miles from your designated landing area. At about 1.5 miles, bring your nozzles back. Make sure that you're trimmed for airway and you've got your rate of descent set before you bring the nozzles back. Adjust the nozzles so that you can stay on airway and on rate of descent at roughly the desired ground speed, which is represented by the S just under the airway indicator there. Once you've got that set, don't touch the nozzles too much. Use the power to control rate of descent. Use the stick to control the angle of attack. Once the designated landing area approaches the nose about a finger's width, 2 fingers width off the nose, bring the power back to meet the end of the prepared surface area. Once you get in close, you can use the nozzles to increase your jet bone lift to reduce that rate of descent while still meeting the landing area, and then use power to reduce to no more than 500 feet per minute descent rate. I hope you found this video useful. If you have any questions, please feel free to contact me. Thank you.